our previous venture into air purification was really based on one element of the air and really making kind of an unnatural level of that element, maybe to use it as a cleaner. And so it doesn't know when to stop cleaning. You know, and so you can't even if you, so when you turn that product on high and are dealing with a smoke issue or something, once that catches up, then you start to get a buildup of cleaning material in the air or ozone in the air. And that's one of the questions we get all the time. And because there's one, they're used to our old product, and two, it's a measuring stick for air purification, even though we're not a purifier, is how much are we making ozone? And if we are, how much?
Well, because we're activating all the elements of the air, oxygen is one of the things that we're activating. Yes, indeed, we do make a little bit of ozone. But just as a frame of reference compared to our old product, we're only making about 1/100th of the amount of ozone that we used to have to make. And the reason that that's true is because we are both oxidize and reduce. And a lot of the things that are out there in the air are easier to reduce than oxidize. When you only have one choice, try to burn it. And if it doesn't want to burn, you just keep hitting it until finally it gets destroyed one way or the other, usually because it combines with a little bit of moisture in the air and helps you out. But because we're doing duplicating outside, we're getting all these elements, and one of them is going to be the one that helps break down something first. And we can't predict exactly which one, but because they're all working in concert, they're all working together, we never ever will get the ozone level up to a level that anybody would be concerned about. Laboratory results, for example, show that in a 10-foot by 10-foot room, that you could have a very difficult time with a naturalizer trying to get above 1, maybe 2 parts per billion of ozone in that real environment. And yet, because of all the other things that we're creating, that's more than enough to create that fresh air in that room.
And tell me, so what does 2 parts per billion mean? Is that high? Is that low?
It is about 1/25th of the normal level of ozone that exists outside.
I mean, that's and I think people are surprised by that, just because of the product that was very successful. We sold millions of, really dealt in that one element. And also, I think that the smell that our old customers or people that have dealt with an ozone product before, they might smell that coming from the naturalizer and go, it's an ozone generator. Explain a little bit about what that smell can sometimes really be.
Well, the smell that you smell, we've always said when somebody says it's ozone, we just kind of agree with them. But actually, there's several chemicals that are actually made. Ozone does have a very sweet smell. Not a harsh smell. It's a very sweet smell until you get to some really high concentrations. But one of the more likely things is that there's nitrogen in the air too, and we're activating it just as well. So whether it's a nitrous oxide or a nitric oxide, in tiny amounts, you're going to be able to sense it. Now, one of the things that you need to be really clear about is that our olfactory senses are incredibly sensitive, and they widely vary. So where some persons maybe can only detect ozone or nitrous oxide at maybe 1 part per million, for example.
Okay.
The next one might have 1,000th of 100 parts per million. And because it's a difference in the odor than you're used to, and your olfactory senses work on differentials, and you can then smell it. Now, that's why it goes away so quick, because it's not, as soon as you're used to it for just a couple minutes, then you can't smell it anymore. But it's all part of the sensitivity of our olfactory senses and the fact that there's a number of things that give us that sweet smell, usually at the same energy levels that we get when we make ozone. So when we used to smell it, everybody said ozone, and so we said, well, that's an easy explanation. But really it's not.